In this example, Mr. Jack's car breaks down and he's got some people pushing his car as shown in this example. And I don't know why they're all pushing in these weird directions, but it just makes our example good. What we're going to do is we're going to look at each individual person, so 1, 2, 3, and 4, and find out who does work and how much each does. So let's start with number 1. So force 1, let's say. What we know is work is equal to FD cos theta. And that theta is the angle between this force and that displacement when they're tail to tail. Okay, so force 1 is going this way. Displacement 1, you could say, is going that way. They're going in the exact same direction. That theta right there is just 0. Okay, so when we put this information in, we got to remember that. The force that we're talking about here, 1,000 newtons, this is just magnitude, so whatever that force is goes in here. The displacement given is 10 meters, and then cosine of this angle, cosine of 0, and don't forget to put your calculator in degree mode. When we do this then, cosine of 0, just remember this thing here is 1, so we just have this number, 10,000. We could call it work 1, I guess. This is the work done by person 1 on the car. We could also look at person number 2 and see how much work does person number 2 do, or do they do any work. Their work also, FD cos theta. If we draw a little diagram like this, their force is going exactly back this way. So force 2 is pointing backwards this way. But the displacement of the car, remember, is still this way. It's still going 10 meters forward. So if I look at the angle between that force, so remember these guys are vectors, if I look at the angle between that vector and this vector, when they're tail to tail, this angle here is 180 degrees. So I'm going to put in cosine of 180. The force, again, just 500, it's just magnitude only, so no negative signs. Sometimes people look at this and say, oh, it's going backwards. I got to put a negative sign. For this equation, because of the way we've set it up with this FD cos theta, these are just magnitudes. So force, magnitude only, displacement, still 10. Again, no negatives are going in. We're going to rely on this thing here, this cosine of 180. This is where our negative sign is going to come from. So cos of 180 is -1. Okay, so when I work this out, this really is, I guess, 500 times 10 times -1, okay, from that cosine of 180. Work then is -5,000 joules. And we could call that work 2. The work done by person 2 on this car, -5,000 joules. Let's talk about person 3. So force 3, let's look at that one. Work done by force 3 goes according to this equation, as they all do. Force 3, if I was to just draw my little diagram again, it's kind of like doing a free body diagram. Force 3 is going straight down this way, but the displacement is going this way. Remember, for all of them, the displacement is going 10 meters, you could say, to the right or maybe to the east or something. The angle here between them, that theta, is 90 degrees. Okay, so when I sub these numbers in, work is 2,000, displacement still 10, again, all just magnitudes. This cosine of 90 is 0. So 0 times everything else is 0. Okay, so the work done, you could say the work done by person 3 on the car, 0. They don't do any contribution to work. I guess they keep the door closed or something. I don't know. I don't know why they're pushing that way. When we look at person number 4, now person number 4 is going this way. So again, if I was to draw this little diagram, force number 4 is going this direction. Okay, and the angle is given right here, 30 degrees. Okay, here's force 4. The displacement of the car, though, is this straight east. Okay, so the angle that I want is this angle. It's the angle between force and displacement when they're tail to tail. So if that's 30 degrees, that's 60 degrees. There's my whole 90 degrees. Their force is 800 newtons. The displacement is 10. Again, all just magnitudes. Cosine here is going to be cosine of 60 degrees. And if I work that out, let's see, that is 4,000. 4,000 joules. And that's it. So 3 of the 4 people do work. Person number 3 does no work. Numbers 1 and 2 do positive work. Person number 2 here does negative work. What we're going to see later is if you do positive work, you're actually adding energy to the system. And if you think back to grade 11, the type of energy that they're adding is probably kinetic energy. So this person's doing work on the car gets moving, it gains speed or kinetic energy. This person does work on the car, it gains kinetic energy. This person does negative work, that actually means they're removing kinetic energy out of the car, so they're slowing it down.